Thanks, Glenn. Appreciate that. So this lecture will be recorded. All of our lectures will be recorded in case some disaster happens, or you've got a power outage, or you've got a blizzard in your area that knocks out your internet, or whatever the case may be. This will be recorded for future reference. So just so that you're aware. All right. We were talking about the calendar, and I wanted to point out that Monday through Thursday days are typically the same or have a similar schedule. So starting at 8 a.m. Pacific, we have a 1-hour warm-up activity. For today, that was our introductions. On other days, that will be some kind of a code challenge, or sometimes we call them walkie-talkies, where you're forced to speak verbally and explain a concept to your fellow students. You'll be surprised at how difficult it can be to speak about these concepts in addition to just doing them with code. And then what's called this guided project here, this 2-hour block, that's our lecture time. So we'll have 2 hours of lecture. We'll take a break in the middle, 5 to 10 minute break. And then we have an hour for lunch. And then the afternoon comprises a few different things. Generally you'll have about 4 hours of time to work on your projects, which is your afternoon assignment. Every day, the afternoon assignment follows fairly closely the lecture content from earlier in the day. So you'll be able to refer back to our lecture content and use that to help you out on the afternoon projects. There will also be these different one-on-ones. You see that overlapping time. So throughout the afternoon, starting tomorrow, we won't do this today, most likely, you'll schedule time to meet with your team lead, and they will go over the work you did on the previous day and give you feedback on it. So day by day, you'll be getting feedback on it. Your team lead will be helping guide you through the content and just making sure that you don't feel too overwhelmed. And if there's something you're particularly struggling with, they will organize a time in these TL support hours that you'll see are both before class and after class each day, where they can get with you one-on-one and give you some personal tutoring, so to speak, but help you through specific concepts that you may be struggling with. So they'll kind of learn your needs and give you feedback at some time that they will schedule with you during the afternoon project, and you'll be able to get extra help from them kind of outside of class. We have these both before class and after class, so that some of these hours might be more convenient for East Coast time zone people. Some hours might be more convenient for West Coast time zone people. So you'll be able to hopefully use whichever's more convenient for you. But then the last hour of class, we have, you'll fill out a form every day telling about kind of how the day went, giving us some feedback on how you thought the material was organized, all kinds of things. We're constantly asking for your feedback here at Lambda School so that we can keep on making things better. And then you'll have this stand-up report where every afternoon you'll get together in your team lead groups, the groups you were just with for fairly briefly with your team leads and 7 or 8 other students. And you will talk about how the day went. You'll talk about what was hard, what was easy, what if you're blocked on anything, if there was just something you couldn't figure out, and you'll be able to have time to kind of help each other out. And you'll get to know your team lead groups really well. Over time, you'll get to know a lot of your students really well, but your team lead groups you will spend some time with at least every afternoon, where you'll be able to talk about your work and assist each other on your projects. All right, so that's Monday through Thursday, right? And this may sound like it's a bit of a complicated schedule. After we've gone through it one time for the first week, it'll make a lot more sense during week 2 and following weeks. But like I said, Friday is a little bit different. All right, so Friday we have, for the first 3 hours in the morning, we don't have a warm-up activity. Starting right at 8 a.m. Pacific, we have what we call a sprint challenge, which is a 3-hour assessment. You'll be given a notebook file, which I'll talk about here in a minute about how we work with those. And it'll have some questions on it, and you'll have 3 hours to answer those questions using Python code or written text explanation or a combination of both. And these sprint challenges are made to assess the things we taught during the first 4 days of the week, so that we can make sure that this content is sinking in. And if we see that lots of people are struggling with the sprint challenge, then we ask ourselves, okay, why didn't this week go as well? How can we improve the content? How can we improve the learning experience? What individuals maybe might need to see this content a little bit more, things like that. Anyway, so Fridays after the sprint challenge, we have an hour for lunch like usual. And then we'll have a half hour to 1 hour review where it'll be kind of an open Q&A time, kind of ask me anything. as me, the instructor, being your question answerer typically. And we'll start off answering questions that are relevant to kind of the week's content if you want to see a particular topic in a little bit more detail. And then we'll kind of open it up to any data science related questions. If you guys have career questions or really anything somewhat relevant to data science, we can discuss it during this time, kind of the end of the week. And that kind of wraps up all the instructional portions of our week. So Friday afternoon, you'll have these one-on-one sprint reviews. So you'll be meeting with your team leads on Friday afternoons, but it'll be for a little bit longer period of time than it is during your typical weekdays. And during this time, you'll reflect on the whole week, on how the sprint challenge went, kind of just to do a full wrap up on the week. Now, you'll only be meeting with your team leads for about a half-hour period on Fridays. So with the rest of the time that's open to you, where you don't have a one-on-one scheduled on Friday afternoon, you'll have free time to work on personal projects, to revisit material from earlier on in the week, to really do whatever to make use of that time and kind of customize it to your needs and whatever you think will be the most useful to you as a Lambda School student. So you got a little bit of flexibility in how you choose to use this time. In future weeks, you will have a weekly careers assignment. We don't have one this week because typically that careers assignment gets delivered to you Monday morning, but we did introductions instead of that careers get together this morning. This Friday afternoon time can be a great time to knock out those careers assignments. Usually they're not very time consuming. You could do it in a half hour, maybe an hour if it's a really time consuming one. But I just wanted to reiterate that this is the general schedule of how our weeks will go. And I wanted to make sure that you had access to this calendar. Let me turn off my notifications here. Again, as a reminder, if you're still looking for the calendar, come to our DS10 channel. The pinned items here at the top of the page, which it's not showing me. Let me click on this. Oh, it was showing me. There's just, usually this pinned section gets so full in the first few weeks with us pinning important documents and things. Anyway, it's this DS10 calendar that's been shared by Josh Ziegler from the Student Success team. And there may be times where we'll slightly deviate from that calendar, but we'll keep you abreast about any of those changes. All right. Yes. All right, let me move this back. Take art and fun away. Okay, and now some of the next few things we're going to talk about is really we're going to spend the first 45 minutes or so, or the next 45 minutes or so of this lecture talking about how to submit assignments here at Lambda School. And submitting assignments here at Lambda School is something that's a little bit complicated. So what I need you all to do now is, first off, I want you to try and follow along with me for this portion of lecture. And in order to do that, you need to do, first off, you need to sign into your GitHub account. If you don't have a GitHub account, go make one super fast. It should take 30 seconds to fill out the form. And also make sure you're logged in with your Google account. We will begin the course by using Google Colab as our kind of notebook editor where we'll write all of our Python code. Later on in the course, we may move to other tools and other resources, but just because it's so easy to get started with, we are going to start using Google Colab for Unit 1 at least. And we may move to local Jupyter notebooks or other items, other text editor tools later on in the course. So log in with GitHub and log in to your Google Drive, or your Google account, right? And we'll get going. So this process is a little bit complicated, but the reason why it's complicated is not just because we want to torture you. It's because this process mimics the workflow of working in a collaborative environment on a code base, right? So the reason why we're having you submit your assignments in what you're going to see is a slightly convoluted fashion is because the process that we're going to use for submitting our assignments mimics a workflow of a professional development environment where you're going to be working on a team, people are going to be sharing code files, and you need to use our same GitHub tools and this similar workflow when you're working in a group. So later on at Lambda School, each 4-week unit, we have 3 weeks of instruction. Those 3 weeks follow the calendar schedule of what I just told you, but the last week is a project week. Now during units 1 and units 2, those project weeks, you'll be doing personal projects. You'll be on your own. But when we get to units 3, 4, 5, etc., you'll be working on group projects. And during those group projects, this GitHub workflow will be absolutely essential for building a group in tandem with other people, especially in a remote setting where you're not sitting literally next to the person you're working with. They might be on another continent, right? This workflow will be really essential for the work that we do. So without further ado, let me get to GitHub and start demonstrating some of this a little bit. But I do want you, again, like I said, to follow along with me. So the first thing I want you to do is go to github.com/Lambda School. And this is where we have all of the Lambda School repositories, right? So a repository is a fancy word that just means folder of files, right? Typically, a repository files or a folder of files represents a code base, right? So you might have a whole website contained in a single repository. You might have all the files for a server contained in a repository, right? But it's a whole project and it's all in one place, all right? So that's what, when you hear me say repository, I just mean a folder full of code files that all are related, all do the same thing, right? So for all of our assignments here at Lambda School, we distribute them to you as repositories on GitHub. So you can see we have something like 1.2 thousand repositories on the Lambda School GitHub account. Now, not all of these repositories are for the data science course. The ones that are for the data science course have been prefixed with DS. So if you're here in the Find Repository and you type DS in quotation marks, it will give you all the repositories that say DS in them somewhere, right? Whether it's in this kind of description or the title. And that'll kind of give you an idea of where our different data science repositories live. Actually, before I keep going, I've just forgotten that I forgot to give you one link. All right, let me share this with you. So switch your brain off from GitHub for just 20 seconds. I've shared another link in the DS10 channel that is a link to a Slido event. Slido is a tool we'll use here during at least the first couple of weeks where you can ask anonymous questions. So even if you have a question that you think is silly or dumb or has already been addressed, feel free to ask it in Slido and I'll revisit it. If you have a question, likely at least a few other students share that same question. So we just want to give you a place where you can ask anonymous questions as we get more used to working with each other in a group. And I wanted to make sure I'd shared that with you so that if something came into your mind as I was explaining this, that you'd have a place to ask it. All right, so sorry that I forgot to say that earlier, but the link has been pasted into DS10, so I'm going to get back to talking about GitHub. All right, so the repositories that we use as a data science class are a little bit different than how some of the other groups at Lambda School might use these repositories. What we have done is we've made a repository for each week of class. Now, when we refer to a week of class here in the full-time course, we call that week of class a sprint, all right? So if you say DS Unit 1, that's for the first 4 weeks, right? The first 4 weeks of class is a unit. Then you'll see here all the different repositories associated with Unit 1. However, you'll see that there's more than 4 repositories here. Remember, there's only 4 weeks, only 4 sprints to the first unit. Why is there more than 4 repositories here? Well, because some of them are old and have been archived, right? So if you see archived here next to the name, that's a repository that's old, it's been deprecated, we don't use it anymore. So if you see archive next to it, please just ignore those repositories. We're only going to use the ones that don't say archived, right? So DS Unit 1, and we're going to work on week 1 first, so we're going to look at sprint 1. All right, you can see here's the old archived Unit 1, Sprint 1, and here's the one that we're actually going to be using. So what I want you all to do is I want you to navigate to this repository. This is the folder of content we'll be using for the first week of class. And I'll also link you to it here in Slack if that's more convenient. All righty. We have a couple of quick questions that have come in Slido. Let me just come back here. Person's asking, what do these graphs mean? What do these little spikes mean? This is a timeline that refers to when changes were made to the folders. So you see some changes were made on this day, and some changes were made on this day. This is a more recent repository, so it has more recent changes been done to it. That's all that these little graphs mean next to the name. Also a Slido question says, how do we utilize the Collab extension on Chrome? We'll talk about that in a minute. We'll get to that in a minute. And we'll talk as well about it saying your commits behind master. So I'm going to archive some of these questions as I answer them. And I may not answer all of your questions immediately. I might wait for a little while to answer them. Oh, and by the way, if you haven't seen in Slido, you can upvote questions. So if you have that event open and you share a question with somebody else, you can upvote it, and questions with more upvotes will kind of rise to the top. So I'll know which questions are shared amongst most members of the class. So I realize it's kind of hard to have Slido open and Slack and your Zoom windows to see what I'm doing and your GitHub to follow along. Just do the best you can. I'll try and go a little bit slow today so that you can follow along with me. All right, so this folder that we're looking at right now contains all of the material for Monday through Thursday of the week. So here's Monday's content, we call it Module 1, Tuesday's Module 2, Wednesday's Module 3, and Thursday's Module 4. This holds both the notebooks that I will be lecturing from and the projects that you'll do in the afternoon. So if I look here at Module 1, you can see Exploratory Data Analysis. That's the lecture notebook that I will work from here in a little bit as I demonstrate some things for you. And then also here's the assignment that you'll work on in the afternoon. All right. So this folder holds all of the files you'll need to do your work during the week. Excuse me. But this is not the only place you can find content relevant to this week of work. You can also look at Training Kit. All right, so to access Training Kit, you can go to learn.lambdaschool.com, and it will probably ask you to log in if you navigate to a specific page. So let me do that. You'll see something like this, and we're obviously in the data science class. This is where all the different groups at Lambda School get their content delivered to them. So you can see all the different courses. We also have some career material, principles for success, a lot of things in here, but you're mostly going to be interested in this data science section. All right. Now, once you're in here, if you click on data wrangling and storytelling, this is our first week of content, right? You'll notice that these days, exploratory data analysis, make features, join and reshape data, make explanatory visualizations, those coincide with the different modules here in GitHub. So GitHub holds the files where you'll actually do your work, and then Training Kit holds supplementary content and written explanations around those different things. So there's reference materials here in Training Kit. They should coincide heavily, if not very closely, to our lecture content. All right. Another thing I'll point out before I kind of keep on demonstrating things with GitHub is that every day of content here at Lambda School, we call it a module. So every module has specific objectives, right? You can see them here at the top of the page. Now, the goal is that by the end of the day today, you can affirm that you can do each of these objectives. So say, I can submit assignments via GitHub, save my work to GitHub. I can load a data set, or CSV, from a URL using pandas.read CSV. I can load a data set from a local file using pandas, from a local file using pandas.read CSV. I can generate basic pandas functions for exploratory data analysis, and I can generate basic visualizations with pandas, right? So every day, our content is broken up. So our whole focus and effort today is you being able to say or answer in the affirmative that you can do each of the objectives. So you'll notice that our lecture content is organized around these objectives. Training Kit is organized around these objectives. And then the sprint challenges, the assessments at the end of the week, are also written to test these objectives specifically and nothing else. All right, so we call that objective-driven development here at Lambda School, and it's how we make all of our curriculum. So please keep an eye on those objectives. They are probably the most important part of our whole curriculum, and a good way for you to kind of test your understanding and see, okay, can I do these things? If I can, then I feel pretty good about where I'm at. So this is kind of also to temper your expectations that you don't have to know all of data science here on day one. You only need to know these 5 things. All right. So right now we're working on part 1, talking about how the curriculum is structured, and I'll show you here in a minute how to save your assignments to GitHub to submit your work. All right. So how GitHub works is that this main repository is called the master version or the master branch. And you'll see that it's the master version because it's here under the Lambda School account. All right. Meaning that it was authored originally by Lambda School employees who have access to make repositories here. So what we're going to do is each of you is going to copy this repository to your personal GitHub accounts. All right. Now the word for that in GitHub land is fork. So when we fork a repository, in plain English, we're making a copy of a folder of files. So this master version is going to live here in Lambda School, and we're not really going to touch it, but we're going to make a copy of it to each of our individual accounts, and then we'll do our work from our individual accounts throughout the week. All right. So what I want you to do is come to this page. If you're not already on this page, the link is in Slack, and click the fork button. All right. Now you notice that I already have it forked. So you can go ahead and click on your account. And after you do that, it will bring you to a page like this. All right. So this looks just like the page we were on before. What's the difference? Well, the difference is now it says I'm in my personal account and I'm working with a forked or a copied version of this. So it says forked from Lambda School. So it tells you where the master version is, but it also says, hey, you're working with this copy in your personal account. All right, so we're going to do that at the beginning of every week. You're going to get a new repository for that week. And the first thing you're going to do is you're going to fork that repository. You're going to make a copy of it to your personal account. And then all of the work that you do will stay here in your personal account. And the team leads will navigate to your work, look at the things you've saved here to be able to give you feedback on it. All right. And that's mostly how we're going to use GitHub. Now, there's a couple of other things I do need to show you, but I hope that I can impress upon you that structure, that there's a master version, and we're all just working on copies of that version on our personal accounts. All right. So before I go any further with this, I want to take a look at some Slido questions. Let's see. Someone asked, I cloned the data wrangling repo last week. It says I'm 8 commits behind master. Should I start over? First off, double check and see if that is the data wrangling and storytelling repo, because as I mentioned, there are a few different repos here. So make sure that you have the data wrangling and storytelling repo. Sorry, this one, the unit 1 sprint one. So we've moved around a lot of content in unit 1, which is why we have so many similarly titled repos here. So just be really careful, make sure that you have this version as your first week of content. And then if it says if it doesn't say that you are even with Lambda School Master, so this here will tell you how, if you have an exact copy of the master or if you have a version that's slightly different. If it doesn't say, like mine does here, that this branch is even with Lambda School Master, what I want you to do is come to Settings and then delete the repository and then re-fork it, right? So, if you're not seeing that you're even with Lambda School Master, delete the repository and re-fork it. All right. We have a question that says, in GitHub, will we ever be accessing archived repo? If no, is there a way to filter the search results? You will not be accessing archived repos. You can. The challenge is that we still have students who have used those past versions, and so we still want them to have access to them. I think you can come to type. There's probably a way to filter it. So you can filter specifically archived repos, but we don't want archived repos. We want non-archived repos. There's probably a way to filter it. Type sources, is that what it is? There you go. Then you don't have filtered, excuse me, then you don't have archived repos, which is great. Awesome. So if you do that, you don't have to fight with the archived repos, but you'll probably have to set that drop down or say type sources, right, when you're searching. All right. So don't let that confuse you. Just ignore the archive repos for now. Those are some repos that were used by earlier data science cohorts. We still want them to be able to access them, but that's not what we're going to use here at the beginning of class. All right. I'm archiving a couple questions that I've already answered. Question, we fork the entire week, correct? Yes. So you'll fork here in the main repository. When you're in this page, it'll say just the title of the repository. If I navigate into one of these folders, you'll notice I'm at a different file path here. So I'm in the main repository, and then I'm inside of the Module 1 Explanatory Data Analysis folder. You want to fork from the root folder from here at the very beginning. And it's good. I've seen this fork number go up, which is good. It means a lot of you are following along and doing the thing that I'm doing. Yeah, just make sure you fork the entire repository for the week. Is there a way to have GitHub auto fork to the latest version of master? That's what it should do by default, is it should fork the latest version of master. Now, if I go and I, as the instructor and the person with access to the master version, if I go and make changes throughout the week, then you'll see, you'll probably see this text change. Anytime anytime that there's changes to the master version that you don't have, it will say that you're a commit behind master. And anytime that you've made changes that the master doesn't have, you'll say that you're ahead of the master branch. So I'll show you that here in a minute. I'm going to take one of these notebooks and I'm going to make a change to it. And I'm going to save it back to GitHub into kind of my personal version of the fork here. And you'll see this text will say, this branch is one commit ahead of Lambda School Master. But when you're even, that means that they match exactly. You have exactly a copy of the master. All right. Can we use another email like iCloud but still link our Google accounts? As long as you're logged into your Google account, you should be good to go. Yeah. So I think the Google account will let you sign up with a different email address, like a non-Google email address. So whatever you use, if you can access Google Drive, like go to drive.google.com and be logged in, you should be good to go with your Google account. Right. Great questions. So every day there will be an assignment that goes with the lecture with the same title. That's exactly right. So we'll have our lecture notebook here, and then the assignment notebook. And I'll have the same name, except the assignment one says assignment at the end. That's right. And so these numbers here, 111, that says this is Unit 1, Sprint 1, Module 1. So we'll do 111 today, and tomorrow we'll do 112. And Monday of next week, we'll do 121, right? So you can kind of, it's kind of an abbreviated way of saying Unit 1, Module 1, Unit 1, Sprint 1, Module 1, right? How we break down the curriculum in that way. If we forget to fork a repository, is there a chance we accidentally edit the master copy, or will we not be allowed? You will not have permissions to edit the master version. Only instructors have permission to edit the master version, so don't worry, you won't be able to accidentally screw it up unless I make a big mistake, which is a possibility, but it'd have to be a pretty big mistake. So yeah, don't worry. You won't edit the master version. You'll just work in your specific copy throughout the week. If you forget to fork the repository, it'll always be here. So you can just, even if you even forget to fork it on Monday, which would kind of be impossible, you won't be able to work on your assignment unless you have forked the repository. So unless you're absent on Monday and you kind of come back into things on Tuesday, you'll probably have forked things. But you can always come back and fork from the master whenever you are ready to. All right. So the next thing I'm going to do is I'm going to answer this next question with the next portion of lecture. It says, after forking or making a copy to my personal GitHub account, does my local GitHub folder auto-update when there's any change in the Lambda repository? And the answer there is no. It doesn't auto-update. So if I go and work on my assignment this afternoon and I make some changes to this file, it will not automatically update in GitHub. I have to explicitly tell GitHub that when I want to kind of save my changes back to GitHub and overwrite what's here with my updated work. All right. So that's what we're going to go over next. I'm going to show you first off, how do I take one of these notebooks and open it in Google Colab? And then I'm going to make some modifications to that file. And then I'm going to show you how to save it back here to GitHub. All right. So the next thing I want you to do, so following along with me again, is come to collab.research.google.com. All right. I'll type that in Slack as well. collab.research.google.com. All right. And when you do that, it'll bring you to this kind of a page. It'll show you some maybe recent notebooks you've been working on. There's a welcome to Colab repo. But what I really want you to focus on is this GitHub tab right here. So go ahead and click on the GitHub tab. All right. And as you click on that, you might see something different than what I'm seeing, at least initially. It will probably be asking for permission to access your GitHub account. If you're seeing that, please go through that process of authorizing it. That might take you a couple of minutes here. So go ahead and do that. And I'll kind of just maybe blab about a couple of things while you go through that process. After you've done that, what's going to happen is you'll be able to see all of your repositories on GitHub here. All right, so we'll select, okay, here's this week's repository, Unit 1, Sprint 1, data wrangling and storytelling. Then here, down below, are all of the different notebooks within that week's repository, right? So here's the lecture notebook for today and the assignment notebook for today. The lecture notebook for tomorrow, the assignment notebook for tomorrow. The lecture notebook for Wednesday, the assignment notebook for Wednesday. The lecture notebook for Thursday, the assignment notebook for Thursday. You'll notice that they've been pulled out of their specific folders and they're kind of just all listed here in one big go. All right. So what I'm going to do is I'm going to ask a poll. Just so I can make sure that you're all still with me. The poll question is going to say, I have authorized my Google account with my GitHub account. All right, I just want to know how many of you are with me. And I'm going to make this an anonymous poll. So feel free to answer honestly. All right. Just want to make sure that everyone's caught up with me before I move on. Yeah, Travis says, I'm a bit tired, but did I miss something? When I click the GitHub tab, it's just empty, no prompts. I can enter whatever I want, including my GitHub username, but nothing comes up. So if you entered your GitHub username here and nothing comes up, make sure that you have forked the repo from today. Because if you forked the repo from today, at least one repo should come up. That is the repo for Sprint 1. So if you try that, Travis, and you're still not having any luck, and this goes to anyone, if you kind of get bucked off by the process here during lecture and you fall behind, reach out to your team lead, and they're here to help kind of get you back on track and to guide you through that process if there's something comes up that's a little bit odd. That's why I wanted to make sure that you met your team leads before we started lecture today, just so you'd know who to reach out to. Keanu makes a great point. Click include private repos. Yeah, I don't know if these are private repos, but that might do it. Yeah, Caleb says, I had to click allow private repos and allow pop-up windows. Yeah, so if you're using some kind of an ad blocker, this pop-up might not even render for you. I hope it does, but that could be something you have to debug as well. Someone's asking in Slido, I cannot delete the master. I forked over last night. What should I do? First off, you should be able to delete it. You just need to go to the settings section down here to delete, and then it'll make you type in the name of the repository exactly. make sure that you are fully aware of what you're doing. You're not just misclicking. And then if you say, I understand the consequences, delete the repository, it should do it for you. Again, that's in the settings section here on the repo. All right, so if you're having trouble deleting it, please get with your TL and they can help you with it. What do I do if my fork is a commit ahead? That shouldn't be a big problem. That just means you have changes. You've already made some changes to your file is really what it means. So if it says your fork is ahead, then that's not a problem. If it says your fork is behind, that's a problem. That means there's things in the master version that you don't have. All right, so being ahead is good. You're all going to be a few commits ahead by the end of the week because you're all going to make changes to your files throughout the week, but we don't want you to be behind. All right, so if you're having trouble getting everything set up, please work with your team lead. I made a new fork. Now when I open a file, it says something went wrong. If you're having trouble with GitHub, honestly, usually the easiest way to debug things is just to delete the repo and start over. Just refork from the beginning, from the beginning of the process. So often it's kind of the turn it off and turn it back on again of GitHub. Alrighty, so once I'm here and I have authorized with Google, looks like all of you have authorized, so that's good. Find the Unit 1 data wrangling and storytelling. It's probably going to be at the top of this drop-down menu. And then what I want you to do is click on, so sometimes these file names get cut off. If you hover over them, you can see the full file name on the bottom of the page. All right. Open up the version of today's module, Exploratory Data Analysis, the version that is not the assignment repo. So this will be the lecture repo. This is what I will use to lecture from for you guys today. So if we go ahead and click on that, here is the same repository that we saw on GitHub, but now open in Google Colab, a place where we can actually go in and edit it. All right. Now to prove to you that this is the same thing, let's look at this repository. Now, GitHub tries to render the repository, but sometimes it fails. In fact, it's probably going to fail for me right now. But this can be kind of useful sometimes. I want to show you, there it goes. Sorry, something went wrong, reload. GitHub will only give a certain number of seconds for the file to load. So if our notebook is particularly long, or the internet's particularly slow at that moment, or GitHub servers are overwhelmed, or whatever the case may be, sometimes GitHub doesn't show us that repository. There is a tool called MB Viewer, short for Notebook Viewer, and I'll send you the link here in a second once I get to it. All right, NB Viewer. If you are trying to view a repository and the state that it's currently in on GitHub, but GitHub's render doesn't show it to you, you can copy the link and paste it in NB Viewer, and then it will show you the notebook. All right, so this is showing me the notebook in the state that it currently is on GitHub. All right, what I'm going to do is I'm going to go to the notebook in Colab, and I'm going to make a change to it. I'm going to add a text cell and say, make this a big header. I am making a change. All right, so here's something in my Colab version that is not in my GitHub version. All right, so we made a change to the file. The question now is, how do I take this modified file and save it back to GitHub? What this is going to do is it's going to override this version here on GitHub, which we're actually viewing in NB Viewer. All right, so I want to take this version, save it back to GitHub, then override the version that's here, and then this NB Viewer should update and show me the change. All right, so the way to do that is go to File, save a copy in GitHub, and then it's going to authorize with your GitHub account to make sure it has permissions and make sure it's saving it to the right place. And you can give this a commit message. This is just to kind of explain the change you made. Makes a simple change, demonstrate saving work back to GitHub. To the lecture notebook. All right. Hit OK. And it's going to think for a minute. Think and think and think as it saves it back. And then it will redirect you to GitHub. All right. So you'll notice that this page that just popped up for me and this page I was on originally, they are actually the same page. All right. So it's just taking me back so that hopefully I could view my change. But as happens many times, GitHub fails to actually show us the change. So if I come to NB Viewer, let's see if this will work for me. I'm actually close NB Viewer, copy this. Yeah, okay. Then hit go. Let's see, I'm not seeing the change to the file, which is odd. Maybe I've done something incorrect. So down here in this section, GitHub tries to render the notebook, and it should look very similar to what's here. But if it's not, we can click this raw file. And what you're going to see here is kind of messy. All right. This is what is actually in the notebook. All right. So this is the code version of the notebook, not the nice, pretty rendered HTML version. This is under the hood how the notebook actually works and stores its information. All right. So I want to look for, I am making a change. And we can see that the change is truly here in the file, even though it's maybe not rendering here. And you can even see, here's my commit message. Makes a simple change to the lecture notebook to demonstrate saving with GitHub. And it was done 2 minutes ago. All right, so this is telling me, hey, this was changed 2 minutes ago. So I'm kind of wondering why NB Viewer is not showing me the change. This is very odd to me. Anyway, maybe NB Viewer is not working correctly. I don't know. Moral of the story is, we made the change, we saved it back to GitHub, and we can see in multiple ways that the change was registered and that GitHub knows it was changed 3 minutes ago. All right. So what I've just done is very briefly the process you will follow every day when you are working on your assignment. You'll go to collab.research.google.com, go to the GitHub tab, select the repository you want to look at, then find the notebook within that repository that you want to make changes to. Let's maybe look at the assignment notebook now. All right, so here's your assignment for this afternoon. Lots of stuff in here. You will make some change to it. And then you'll say File, Save a copy in GitHub to get it back to GitHub. But before I do this, I want to actually show you one other thing. There's one more wrinkle to this process that I want to demonstrate. All right. Take a look at the top of the page here, and you can see here's the GitHub icon. That tells me that this notebook that I'm working with, its original source is that it's coming from my GitHub repository. But it also has this kind of save icon with a slash through it. It says, this notebook is in playground mode. Changes will not be saved unless you make a copy of the notebook. What this means is, well, Google Colab is a Google Doc. It's just like Google Sheets or Google Docs or Google Slides, right? And then it should automatically save my work as I'm typing, right? So it should make it so I don't really have to save my work all the time. However, if I'm working from the GitHub version of that repository, that autosave functionality goes away. It gets turned off, all right? So one other thing that I highly recommend you do is that every day after you have pulled the GitHub notebook into Google Colab, is so go to File and then say Save a copy in Drive. All right. You'll notice this notebook is exactly the same as the one we had before. But the biggest difference is that now instead of having the GitHub icon, it shows a Google Drive icon and it says copy of, right? This means that not only now do we have a version of the notebook in GitHub, but we also have kind of a second copy of it in Google Drive. Now, you'll also notice that the save icon with the slash has gone away. What this means is that this notebook does have the autosave functionality, right? So as you're working throughout the day, I actually recommend that you work from the Google Drive version and not the GitHub version. Now, what that means is that, you know, if I'm working from the GitHub version and I make some changes and I accidentally close my tab, then I'll have lost all of my work. And that's a really sad thing when you've been working on an assignment for 2 hours and making good progress, and then you accidentally delete it all, right? The whole reason why we're trying to use GitHub is to prevent us losing work, which is why we're saving all of our work kind of to a website on the cloud and somebody else's servers and not on our local machine, is so that even if my machine crashes, if my machine breaks, if it gets struck by lightning, I don't know, I will still have versions of my notebook saved online, all right, in a way that's publicly accessible to your team leads so they can view them and give you feedback as well. However, if you work from the Google Drive version, it will automatically save your work as you work on it. And you can still save to GitHub from the Google Drive version. You just have to say, File, save a copy in GitHub, just like before. The difference is here that this file path is not complete, all right? This file path does not contain the Module 1 Exploratory Data Analysis part of it. This file path just puts us in the whole repository, right? It's only in DS Unit 1, Sprint 1, Data Wrangling, and Storytelling. So if I want to put this specifically in the Module 1 folder, I have to add the path to the Module 1 folder at the beginning of the file path here, all right? So saves copy of assignment to Module 1 folder, all right? So go and save that. It will save to GitHub just like we saw before, but now this version is what's in my Module 1 folder. And you'll notice I didn't rename it. I left the copy of on there, right? So because when I was saving back to GitHub, it saw a file that wasn't in GitHub before, it didn't overwrite the new file. It added a completely new file here, right? So here is my copy of LSDS111, Exploratory Data Analysis, saves copy of assignment module folder, and we can see that it happened 20 seconds ago. All right, so let me wrap up this process for you. Here's what I want you to do. I want you to fork the repository, the weekly repository, at the beginning of the week. And I'm typing this out so I can paste it to Slack, right? And then after that, I want you to find the notebook that you want to work with from within the repository, and then go to collab.google.com/research. What is it? collab.research.google.com. And open the repository, the notebook, excuse me, that you want to work with in Google Colab. Work on it. Make a copy of the notebook to Google Drive. I'll even pull this over so you can see what I'm typing. Make a copy of the notebook to Google Drive. Do your work. Make changes to it. Use the drop-down menu to save your work back to GitHub. But as you do that, make sure you have the file path correct so that it gets saved to the right place in the repository. Now, hopefully you can kind of see what I meant at the beginning of lecture when I said that this assignment submission process is a little bit convoluted. But the reason why we're using this convoluted process is because this mimics the workflow that you will use when collaborating with other people on your work, when working on a code base, when combining your work with the work of others. All right. There's one final step in this process that I haven't told you yet. All right. The final step is submit a pull request of your work. All right. Now I'm going to paste all of this to Slack for your reference. It's also in the lecture notes from today in a much more verbose format with screenshots and everything. All right. But let me show you what I mean when I say open a pull request. All right. So how GitHub really works is there is some master version, right? Here's the Lambda School master version of this week. Pretend that these files here were not just kind of assignment files. Pretend that this was a website and that we were web developers, right? And we wanted to work on the website. Well, if we changed the master version directly, it would likely change the website almost immediately. In some cases, depending on how a company set it up, changes to the master would change the website immediately. That's called continuous development or integrated development, right? But in other scenarios, we would make a change here, and we might have to wait until the person who ran the project went and physically told the website to take those changes to be updated. Well, if everyone who's working on the project is just making changes to these files all at the same time, and then there's some likelihood of them overriding each other's changes, and there's likelihood of us going in and accidentally breaking something, and when it gets pushed to the main website, gets made live, the website crashes and goes down because we made changes that weren't approved, all kinds of things. So the format of having a master version and then have everyone else work on the smaller forked copies, the reason for that is so that we can always keep a pristine master version in the way that we want. All right, so what happens is you might, as a web developer, and I'm just using a web development example because I think it's easier to reason about than working as a data scientist, you might fork this repository that has the company website on it. You might make a change to the sidebar, right? And then after that, you'll say, okay, I think my changes are pretty good. I want to get these onto the master version. What you will do at that point is you'll open a pull request. And a pull request says, hey, I've made some changes to my forked version, and I think that those changes should be incorporated into the master version. They should make it into the website. However, there's a review process that happens before those changes get actually put into the master version. People are going to look over your code. They're going to test your code, make sure it's not breaking anything before it actually gets made part of the master version. So essentially, the action of submitting a pull request is me recommending changes to the master version, right? So I work on my assignments throughout the week as a data science student at Lambda School. And then I open up a pull request, and that pull request says, hey, Lambda School master, take a look at my work and tell me what you think. If you think it's good, then merge it into the master version. If you think it's bad, then you can kind of maybe reject my work or tell me what you want to change, want to have changed. Now, the one place where we stop short of the full process here of a master version, we all fork it, we make changes, we submit a pull request. That pull request is saying, hey, take the work I've done and maybe incorporate it into the master. The one thing that's not going to happen during our process is I am not going to merge your work into the master version. That is the tiny wrinkle where this does not mimic a larger code-based workflow. And the reason why I'm not going to merge it into the master version is because we're going to use this same version for the next cohort, or maybe a slightly altered version of it. And I don't want to have all the answers in there when the next cohort uses these. And you guys are going to do all your work and you're going to put all the answers on the assignments. And I want students to start without that and then put it in, right? So why am I having you open a pull request if I'm not going to actually accept your changes into the master version? Well, let me show you. All right. So open a new pull request. You'll see here's the two changes that I've made, different times I've saved it, and here's my the messages that I left. It'll even show me In the raw version, the changes that have been made, there's kind of a lot of changes that have been made because I added a whole new file. Remember my copy of LSDS1. So if I hit create pull request, give this a title. Now, when you make your pull request, put your name first. Work for module 1, for example. So here's my name. Here's what I've done. Create my pull request. All right. There we go. So right here, you can see this says merge pull request. That's what I would do if I actually wanted to take these changes and make them part of the master version. You guys probably won't see this merge pull request button because you don't have permissions to actually merge the pull request. So when I said before that I could merge this, if I made a big mistake, the big mistake I would have to be is clicking this button and going through with it. All right, you guys don't have those permissions, so you won't see this step. Your pull request will kind of just hang out there. All right, but you'll see that we have this pull request tab on the master version of the repo, right? And you can see here, here's my pull request. A couple of you have already been following along with me and issued up some. That's awesome. So the reason why we have you issue pull requests is because now there's one place where the team leads can go and find their way to all of your work, right? Say Gwen was my team lead, and she came and said, okay, I need to look at Ryan's work from yesterday to give him feedback, see how he did. She can come here and click on my pull request and be taken directly to my repository to look at my commits, and it can then come and look at my files. All right. So this is the final step at the end of each week, or at the end of each day, is you need to submit a pull request. Now, you only have to submit a pull request once per week. Any future commits, so commit is a GitHub word for just saving your changes, right? So if I save my changes to GitHub, on future days, even after the pull request is open, they will automatically be added to the pull request. So you only need to open a pull request once at the beginning of the week. Typically, your team leads will be talking with you, and in your stand-ups on Monday, or maybe even before that, as you're working on your assignments, if they don't see a pull request from you, they'll say, hey, have you submitted your pull request yet? I can't see your work, and I need to be able to see your work, obviously, to give you feedback, right? So you'll fork at the beginning of the week. You'll do your Monday assignment work in the afternoon, but by the end of the day on Monday, every week, you'll need to have opened a pull request so that the team leads can access your work and see what you've done. All right. So that is the overview of how we're going to submit our assignments. Now you may say to yourself, I am totally lost. And if you're totally lost, don't worry. We will do this process every single day until the cows come home. And you have your team leads to rely on. You have other members of your group and in the class to get questions answered if you need help going through this process. You're going to get really good at it very soon. So don't worry too much. Don't be afraid to ask questions. Don't be afraid if this is confusing. I know that it's confusing. I've had to learn it myself as well. Over time, it will become more natural, particularly when you start working on actual projects and collaborating with teams on projects, and you'll see why we're forcing you to use GitHub and use this process. You'll hopefully it will all start to connect for you in time. Keanu asked a good question. He says, in a real project, what if two people made pull requests that collided with one another? In other words, two people made pull requests that made changes to the same file, and particularly the same lines of the same file. How would they be merged? Well, typically in the merge process, there's a menu that comes up and it shows you one file on the left-hand side and one file on the right-hand side. And you get to pick and choose, say, okay, I want to keep that line from that file, but I want to throw away that line from that file. That's what's called a merge conflict. And that's another reason for why we have the master version, is that, whoever's your project manager and is managing the master version can come in and get together with you as you're submitting those pull requests and go line by line through your work, make sure that it all looks good, make sure that it's all the way they want. So that's called a pull request, a merge conflict. It's not called a pull request. It's called a merge conflict. Those do come up. They're a bit harder to deal with when we're working with our Jupyter notebooks or Google Colab notebooks than when you're kind of working in a web development environment. So we probably won't run into any issues like that for a little while during class, mostly because you'll just be working on your own most days during class, but you will end up running into those, and they're kind of a pain. They're kind of a pain because it's tedious to go line by line and sort things out, particularly when our notebooks, let's see, our notebooks, this is truly how the code of our notebooks is written. So you would not be going line by line through your rendered notebook like this. You'd be going line by line through this nasty version, which is a lot more difficult to reason about. Merge conflicts with IPython notebooks are particularly challenging. All right. Good, good, good. Good replies from your TLs as well. All right, so let me look at Slido real fast, and then we'll take a break. After we take a break, we'll truly dive into the lecture notebook here, and I will walk you through the things that are here. So that you notice the first section focuses on the first objective, can save assignments via GitHub. And this whole first section has a written out explanation of what I just told you, in case you need to refer back to it after lecture's over. Now, you'll have the lecture video. You can come back and rewatch portions of the video, or you can kind of read through this and see if you can, remember to submit your pull request. Here's the pull request button if you missed when I was showing it, et cetera, et cetera. So when we come back from our break, we're going to start here on objective 2, and we're going to practice loading data sets and working with them. But before we take that break, I want to just wrap up this portion of lecture with the Slido questions. Someone says, woo, I did it, save it back to GitHub. That is awesome. All right. So the first question that's on it says, after forking, does my local GitHub folder auto-update? No, it doesn't. You have to go to File and physically save it back to GitHub. That's the only time that the GitHub version will update. All right. How do we utilize the Colab extension on Chrome? That is a very good question. So one other thing that I'll mention is, remember how I told you to open your notebook by going to colab.research.google.com/GitHub, which it just did something funky to me, right? And then find it, do all this whole process. There's actually an easier way to do this. You can navigate directly to the notebook that you want to open. All right. Say I wanted to open this copy of version again. Oh, that's the Lima School version. All right, here's my version, right? Here's the copy of, and I'm here looking at just this notebook on GitHub. If I want to open only this notebook, you can download this Chrome extension, and I click on that button, and it will open it automatically. So that skips the whole pop-up thing and the drop-down menu and all that stuff. But I had to show you the pop-up menu thing because you have to authorize Google Drive with your GitHub first. That's why I had to show you the slightly more long and verbose method. If there's a team lead who has access to this Google Chrome extension, and there is a version of this for Firefox as well, I believe. If you guys could find a link to that and paste it in the DS10 channel so that students who want to use this Chrome extension to be able to open their notebooks more easily from GitHub can do that, I would greatly appreciate it. I do not have the link at the ready to drop. So yeah, if what I just did seemed cool to you and easier than, you know, kind of working through the drop-down menu, then absolutely use it. I do think it's easier, but always good to have multiple ways of doing things in case for whatever reason one day the Chrome extension's on the fritz or something like that. All right, so that goes with the second question that was talking about the Colab extension on Chrome. By the way, I'm archiving questions as I answer them, but if you're interested in looking at the archive questions and you're looking at Slido, you can click the archive button and you can see previous questions. Many times, team leads or other people who have responded to those questions or replied to them, so there's still like helpful information in there. I won't delete them completely. I'll just archive those old questions. Question, so our pull requests a daily process thing for each assignment, or are they weekly, just done every Monday? They're weekly. So forking and submitting a pull request, those are done on Monday, and those should cover you for the whole week. The daily process is really what I've just shown you of open your notebook and get in Google Colab, make changes to it, save it back to GitHub. And that's really what you'll do to work on your work throughout the other days of the week. All right. Are we getting feedback on our submitted assignments? Yes, you should. You'll have, if you remember from the calendar, this daily one-on-one time, you should get some feedback on your work from the previous day. Which is one reason why we're not having those one-on-one reviews today, is because there isn't any work from yesterday to review. So yes, you should get feedback. When we submit our pull request, will we do it for each assignment? No. So every time you save a new version of your assignment to GitHub, it will automatically update your pull request. So it'll get added to your pull request automatically. So you just need to open that pull request at the repository level one single time during the week, and that should cover you for the whole week. Once you've saved a copy back to GitHub, does it auto-save subsequent changes to the copy in GitHub? No. So there's no auto-saving to GitHub. Every single time I want to formally change the GitHub version, I have to go to the drop-down menu and say, save a copy in GitHub. Now, the Google Drive version will auto-save changes that you make, but only to the Google Drive version. You have to then take your version of the file that exists in Google Drive and then explicitly tell it to go back and to make those changes on GitHub as well. All right. Is it preferred that we save our Drive copy to GitHub as copy of, or can we remove that and overwrite the file in favor of other tidiness? Please take the copy of out, actually. I prefer that you stay as tidy and organized as you can with your GitHub. That's also going to make it easier on your team leads. I just left the copy of in so that I could show you that if this file path was not exactly the same file path as something that's already on GitHub, it's going to make a new file. That's the only reason why I left that in. So that's a great question. Please do take that out as you're working on things. Great question. All right, and with that, we're through all the Slido questions. Again, this demonstration, even though it's kind of broken up by different things that I was explaining, should be in the video here later today. Remember, there's also a lot of text in the lecture notebook about this. What we're going to do is we are going to take a 7-minute break. And when we come back from this 7-minute break, we will get into the other objectives in the lecture notebook. Thanks, everybody. I'll see you back here in 7 minutes. All right. Whew. Come on back and we will get going again. We're going to kind of break away from our GitHub stuff and we're going to focus for the rest of the lecture on really just learning how to do some basic data, exploratory data analysis in our notebooks here in Google Colab. Hopefully most of this first assignment is a little bit of review for you from the pre-course work. Maybe there might be a little bit that's new, but that's okay. We're going to keep things a little bit light here on the first day just to kind of get familiar with the process in the first place. But we did have a couple of new Slido questions come in during the break. Person asked, we should only save our copy in GitHub, no need to save both, right? So when I say make a copy in Drive, you only need to do that once. So if I come here to my Google Drive, I go to recent, right? You can see here's my copy of, and that'll stay this way forever, right? It's kind of nice also to have copies of all of your assignments in Google Drive because it's good to have a backup and also just a place where you can get to them quickly. So another thing is by the end of your time in this course, or even the end of Unit 1, you're going to have a lot of notebooks in Google Drive. You're having a lot of notebooks on GitHub. So please be thinking about how you want to organize your work, putting things in folders so you can access it quickly. By the way, sprint challenges, that 3-hour assessment that I talked about that happens at the end of each week, that is open note and open book and open Google, right? So the better you follow along, the better you take notes, the better you make references for yourself. You may need to refer back to something from earlier in the week on the sprint challenge, and that'll be easier if you have your files organized in a clean way so you can get to things quickly, all right? So I'm going to just one more time go through this final process, right? So what I'm going to do right now is just what you would do on the main day. Speaking of pre-course work, will we get any feedback on that work that we did? Likely not. We've already looked at the pre-course work. If you're here, then we liked what we saw. That's your binary. It was good, it was bad on the pre-course work. But you're probably not going to get any more fine-grained feedback on the pre-course work than that. We're working on building in some auto-grading functionality in the pre-course work so that you'll know while you're doing it if you're doing it right or not. But we haven't released any of that yet. So sorry, I know that you'd probably like more feedback there, but it's just we get too many pre-course work submissions to grade them all and give them all feedback one by one. All right, so another question. I was currently driving out to the library to try and use one of their computers to follow along, but I missed some info. Where will the recordings be at the end of the day? They will be in the DS10 videos. And you're right, I'm not screen sharing. Let me make sure I do that. All right. By the way, there's a whole bunch of other data science related channels that if you're not a part of, you should definitely join. There's DS General, DS Random, DS Resources, DS Help is a super awesome one, etc., etc. So go ahead and you can click on any of those channel links and get added to those channels. And if I'm forgetting any TLs, go ahead and throw them on there. There are also in Slack, there's a lot of geography-based channels that are really useful. So if you are in Philadelphia, search for the Philadelphia channel or the Bay Area or Salt Lake City or Utah or any other place, wherever you're at, you can get connected with students that live close to you locally. And there are monthly meetups of Lambda School students that happen in most metro areas. And even sometimes, you know, we had some students get together in Thailand before, like, join those geography-based channels. Those are also, if you're looking to find a job later on in a specific geographic area, go ahead and join that area too. If you know you want to work in San Francisco in the Bay Area, join the Bay Area channel. Sometimes job leads and other things will come up in those channels that won't come up in the normal channels. Alrighty, so lots of resources, throwing a lot of stuff at you. Here's what I'm going to do one more time: is I'm going to open this copy of LSDS 111 in Google Colab, and I'm going to use the Chrome extension. All right. So here is, oh, that's the assignment. That's not the one I wanted. I want the lecture notebook. My bad. So, oh, Aaron's got us covered with more awesome channels. What I'm going to do is I'm going to open the lecture notebook for today. All right. And this is going to be the official lecture notebook that we're going to actually use for class today. All right. There we go. Finally got the right one. Oops. Come on. There we go. All right. Now what I'm going to do is I'm going to save a copy in Drive. And another good reason to save copies in Drive is you get all of the Google Doc sharing functionality, right? So I can now click share in this link, I can copy this link, and I can give it all to you, like I have just done in the DS10 Slack channel. And this is where all the lecture notes will be held, right? So as I work and I type code in this notebook, you should be able to access all of that in the link I just shared with you. So as I'm working, if you go back and visit my link, you might have to refresh the page. You should see this start to populate with the work that I'm doing throughout class today. Keanu asks, is there a way to have Google prompt us where to save the copy? I don't know that there is. I think you kind of just have to make the copy and then go back to your Google Drive and try and organize things after the fact, which I know is a pain. There might be a slicker way to do it, but not that I am aware of. At least not that I use consistently. You can see my Google Drive is a mess, but all right. Someone saying, you know, they had the wrong repository, redoing it. Is that okay? Yeah, go ahead and redo it. You can even copy files between repositories, or if you have something that you just want to save it to a different repository, remember, you just have to give it the right file path, right? So if I'm here in my Google Drive version and I say save a copy in GitHub, I just have to select the right repository and give it then the right file path within that repository. I could take this notebook and I could save it anywhere on my GitHub that I want from this drop-down menu, right? So if you've already done some work on some of the assignments, go ahead and do that. Now, one thing that I will say is if you are a person that likes to work ahead and you want to look at Tuesdays, Wednesdays, Thursdays content, please, please, please do not save that work back to GitHub until the day that we're actually working on it, all right? So feel free to look ahead and work ahead, but you need to be working with the Google Drive versions of those if you're working ahead, and do not save them back to GitHub. If you do save those versions back to GitHub, what will happen is if I make any changes to like Wednesday's content before we get there, and I change the master version, when you go to pull those changes in from the master version, you'll get a merge conflict. And it'll be a huge pain to try and fix that. So if you're working ahead, only work from the Google Drive version. Don't save your files back to GitHub until lecture has started on the day that we're working on it. All right, so be careful about that. And another thing I'm going to do every time we have a new notebook here is I'm going to rename it. I'm going to say LS DS10, and this will be the version that's specific to your cohort. Yeah, and if you live in a kind of a rural area, not close to any major metro area, you might have to look for a more major metro area for those geography-specific channels. There's probably something that's within a state or two of you, but you know, maybe it's not exactly your town. All right. Woo. All right, so another thing I'll mention is that our lecture is slated to end in about 20 minutes based on the calendar. We are going to go overtime. I can tell you that right now. That's something that happens often on the first day, just because there's a lot to go over. Here's what I'll say is, depending on how far I go over lecture, just push your lunch back by that amount of time. So still please take a full hour for lunch, and just start on your assignment maybe a little bit later than you typically would. All right, so I want to make sure I get to explaining all of these objectives, because I need to at least do the I do portion and demonstrate these for you during the assignment, so that you have something to reference, so you've seen these things at least once before your assignment. All right, so I'm going to delete the I am making a change, because I'm going to make some other more substantial changes here. All righty. Let me make sure I've got everything. I think I thought I had some lecture notes open. Let me open those quickly. Okay, got those back open. By the way, is my font here big enough to read, or do I need to make it bigger? Please, if you can, type along with what I'm about to do. It might be a little bit hard to follow along at some points, but do type along if you can. A little bit bigger for the font. How's that? Alrighty. Sweet. Let's do this. All right. So our second objective for the day, we want to be able to say that we can load a data set from a URL, right? So the data sets that we're going to work with in class, they are generally CSV files, comma separated value files. And we're going to practice using this flags dataset file. So there's a website called the UCI Machine Learning Repository. UCI stands for UC Irvine, the California University, and they hold a bunch of data sets here on this website that are really popular for just teaching some basic data science concepts, right? So if you're here on the homepage, you can see here's their most popular data sets. Now, on your assignment today, what you're going to do is you're going to pick your own data set, and you're going to do some of the things you've seen during lecture, but you're going to do it on your own data set. Now, for your assignment, I want you to pick from these data sets here on the right-hand side, all right? The reason why I want you to pick from some of these ones is they are more popular, and because they're more popular, they're less likely to have weird issues with them, all right? So please start with one of these data sets on your assignment today. That's where you can find it. We're going to demonstrate using the flags data set from UCI. It's not in the top 10, but it's still a pretty popular data set. All right, so here is the flags dataset URL. And you can see here that UCI has a lot of information about this dataset. Okay, it's a multivariate dataset, so it's got more than one variable. It's got both some categorical variables and some integer variables. It has 30 columns. I think we actually see it has 31. It has no missing values. That's nice. It's been visited 270,000 times. Right? It's a pretty popular data set. It's kind of old. It's from 1990, so on and so forth. All right, cool. We can also scroll down and we can see this attribute information. So these are the different columns of the data set, and this is what they mean, right? So we have name, name of the country concerned, landmass, zone, area, population, et cetera, et cetera. So we sometimes call this a data dictionary. It means it's just an explanation of what the different columns of our data set mean. All right, so what I want to point out is that whenever you are loading a new data set that you haven't worked with before, what I want you to do is I want you to go in and I want you to actually read this stuff. I want you to actually look at this table to learn more about the data set. I want you to actually look at the data dictionary to learn more about the data set. Because the more you understand about the data set, the earlier you'll be able to pick up on any problems. All right, so it says this data file contains details of various nations and their flags. In this file, the fields are separated by spaces, not commas. With this data, you can try things, blah, blah, blah. So this is interesting. It's probably going to give us a CSV file, but it's not using commas as the separator. It's using spaces, right? So even right there, that little piece of information might clue me in about something that could go wrong as I'm loading the data set. And there's just important things that I'll read here that will be useful. Now, the next thing I want you to do after you've kind of read this summary information is I want you to look at the raw file. Every single time before you load a data set, look at the raw file. All right, so let me show you how to get there from UCI. If you click here on data folder, it's going to take you to this folder that has a whole bunch of different files in it. Now, UCI, even though if their files are acting as comma separated value files or some kind of CSV file, they typically don't give the file extension .csv. You'll see .data used for the file that has the data in it for the CSV file. And then flags.names is usually just a text file that holds this same data dictionary information. All right. So both of those will be useful to us, but the raw file we want to look at is flag.data. So as I click on that, you'll notice that it downloaded to my machine, and this is the 8th version of it on my machine because I've used this data set a few times for a few different lectures. So I'm gonna open text edit. Oh, I don't want the raw version of what I was looking at before. All right. And from here, I want to go to downloads and I want to open flag 8 data. All right, so here is the raw version of the file. Now, what's interesting to me here is this is not space separated. This is comma separated. So I don't know what they're talking about on the UCI page because you can see there's commas separating the different values, but each new line character is separating different rows, right? So I've got a whole bunch of different countries and then different information about them in each of these different commas. And so like, okay, the first one here, the first column should be name. Good. Second one is landmass, says kind of what continent it's in. Afghanistan is 5, so Afghanistan is in, I think this is supposed to say 5, is in Asia. All right, so not a perfect resource. There's been some typos here, but this is what I want you to do before you start is look at the raw version of the file, because as we look at this raw version, this will tip us off about things that might go wrong, right? Scroll up to the top, scroll up to the bottom, take a look at it, see if there's anything wonky going on. Now, I think this is a pretty good file. It's pretty clean, but we are still gonna have some issues with it as we try and load it. All right, so what we're gonna do is we're actually going to, even though we downloaded the raw file, we're not going to upload this from the raw version of the file. We're going to upload this to our notebook using the URL of the file. So the real question is, well, how do I get this URL, right? Let me show you. Here in the data folder, you notice that when I clicked on this flag.data, it started an automatic download. What that tells me is that the URL that this link is pointing at is the same URL that I can use to get this into my notebook, right? So if I hover over this, you can see at the bottom, archive.ics.uci.edu/ml/machine learning databases/flags/flag.data. That's the URL that I want. But if you don't want to copy that out, you can right click and say copy link address. All right. And if you right click and say copy link address, let's see, I don't need this anymore. You'll get that same URL that we saw as we hovered over the link, right? Now I've already taken that URL and I've put it in here so that we don't have to type it out. It's already here in your notebook, but just so you know, that's where this URL came from. Now I'm gonna wrap it in quotation marks to turn it into a string because Read CSV expects a string that is the URL of where this data set is located. All right, before we actually import this, I want to show you one other way that you can look at the raw version of the file. All right, so that's using this curl command. All right, so if I use !curl and then give the URL of where the notebook is at, notice that this version is not as a string, it does not have quotation marks around it. This will grab the raw version of the file and output it in my notebook. There you go. So this is exactly what we were seeing in text edit, but it's here as a cell in my notebook. So you may or may not prefer one version of the other. Both of these will accomplish the same task, but I want to make a comment about what's actually going on here with this curl command. All right. First off, this curl command is not Python. This is not a Python command. This is what's called a bash command or a shell command. You can read more about using shell commands in IPython notebooks here at this Jake Vanderplas link, right? So whenever you see something that's prefixed with this exclamation point, it's sometimes called a bang or bang character. This means that what follows after this is not Python. What follows after this is a shell command. Now, all computers come with some kind of a shell. Now, if you're on a Mac or a Linux-based machine, you might have something like this terminal where I could take this shell command and run it, and it would generate this output, right? So what I'm doing by putting this exclamation point here is I'm saying the text that I'm about to type next is not Python, but it's a shell command. It's something that we would do kind of from the guts of our computer. And each notebook has a server, a computer attached to it, right? We can see properties about the RAM or the disk, and we can see that we have a runtime, right? One moment. Excuse me. All right, so what we're doing with this shell command is we're going into the computer that is hosting this notebook, and we're running this shell command as if we were going into that computer, opening up its terminal, and running this command. So there's a bunch of interesting shell commands we could use to do things with our data sets. I'll show you a couple more of them tomorrow as well, right? So just know, if you see the exclamation point, this is not Python, this is a shell command, all right? But there's multiple ways to look at the raw version of the file, the curl command, or download it and look at it in some kind of a text editor. All right, but I do want you to look at the raw version of the file before you try and load it in. All right, so we're going to take our URL. We're going to save it to a variable. We're going to call that data flag. We're going to call that variable flag data URL. All right, then we can use this variable to read in our data set, which is what we're going to do down here. Now, this output gets kind of long and will make your notebook kind of long. So one thing you can do is you can click on these three dots and you can say clear output, and it will remove the output. I'm going to do that just because it gets kind of annoying having the long output there, to have to scroll past it every time. But I'm going to make a new data set, and I'm going to say flags equals, oh, I need to import pandas. Actually, let me just run this. pd.read CSV. And then the URL that I want to read this CSV in from is flag data URL. And PD is not defined because I haven't imported pandas, right? So let me make sure that I actually do that. Now that I've imported pandas, I should be able to get the flags data set. All right, and I'm just going to do flags.head here. The .head command will show me just the first 5 rows of a data set. So it's just going to show me 0 through 4 here. All right, I could also do flags.tail, and that would show me the last 5 rows of a data set. And I can also pass in an integer value here to these parentheses. And if I pass in a 10 here, it'll show me the first 10 rows. If I pass in a 10 here, it'll show me the last 10 rows. I can put any number here that I want and get that specific number of rows. But for today, 5 rows is good enough for me. So I'm going to put this back and let it just give me the default 5 rows. All right. So here's my question for you. As you look at this data set and you look how it's been read in with pandas, does it look right to you? Or do you see something that's off? I'll tell you, there is something that's off. What do you think could be going wrong as we read in this data set? And just let me know in Slack. Go ahead and type any answers in Slack. I've got an eye on both Slack and Slido. Okay, good. The column headers are weird, right? So this top line that's bold is supposed to be the column headers. That's why it's bold, right? So we have got the row indices here in bold, and I've got the column headers here on bold. So what do you think Pandas read CSV is using as the column headers? Yeah, good. It's using the first line of the data. And how could we verify that? Well, we go back and we look at our raw data. We say, oh, this Afghanistan line, that's being read in as the column headers, right? And we don't want that. We want column headers to be more useful ways that we could identify these different columns, right? I might want the first column to be name, and the second column to be landmass, and the third column to be zone, and then area, right? So one thing to know, and this is something that's common with lots of data sets, but particularly UCI data sets, is that UCI data sets do not come with column headers in the file, right? If we saw a row of column headers, we should see it right here at the top of the file, but we're not seeing it because the data file just holds the data. It doesn't hold any column headers. And read CSV is looking for the first line of this file, and it's going to try and use the first line of this file as the column headers, right? Because if there were no column headers, we got this weirdness, all right? So my real question for you is, you're going to run into issues like this from now until you're dead as a data scientist, all right? You're going to run into things that don't work the way you expect them to work. And one of the biggest skills you're going to develop in your time here at Lambda School is how to debug your own problems and how to find your own answers. So one of the first and best ways to start solving those answers is when you see something that happens and it's not what you expect, go look at the documentation. Now, each library that we use has documentation that's been written about it. And there's a few different ways to get at that documentation, right? So if things go wrong, investigate and try and figure out why. The first thing is you can use the help command, all right? And I can say pd.read CSV. The help command will show me the documentation for this specific function, all right? Now it's kind of been all outputted here as plain text, but it's got explanations of the different parameters that we could pass to pd.read_csv to change how pd.read_csv would work, right? So I could give it a string to a file path. That's what I gave it here as the first parameter, right? Remember, we just passed it a URL that represented, excuse me, we passed it a variable that represented the URL where the data set was located as a string, right? But there's all these other parameters that we could pass to read CSV that would change its operation, right? Another way you can get at this documentation is you can put a question mark and then say pd.read CSV. This will bring up the documentation in a little window here at the bottom of the screen, rather than putting it in an output cell. But this is the same thing. We get a little bit of text formatting here with some colors, but you'll notice it's exactly the same text. Wait for it. That's what we had above, right? So notice this is the same as this. All right. Both of these are good ways to look at the documentation, but there's one more way. Actually, there's more than one more way, but there's at least one more way that I prefer. I prefer to just say pandas read CSV to Google and look at the documentation on the actual pandas documentation website. All right. Now, the reason why I like this is I think the text formatting is a little bit easier to see. They've got bolded parameters here that are easier to see. They use different fonts to indicate what's code and what's text. Anyway, I like this a little better. It's a little bit easier for me to read, but it's up to you how you want to interact with documentation. We're going to be looking at documentation basically every day, and getting good at reading it takes some practice, all right? So let me show you what's going on here. This first row, this is called the function signature, all right? It has all of the possible different parameters that we could pass to this function, and it also has their default values, right? So if I don't specify one of these parameters, then by default, it will use what's here, right? So there is a header parameter, right? And if say that says the default is infer, right? So I come here and I look for header equals infer, right? So if I don't pass the header parameter, it's going to try and infer what the header is from the first row. Row numbers to use as column names and the start of the data. The default behavior is to infer the column names. If no names are passed, the behavior is identical to header equals 0, all right? And column names are inferred from the first line of the file. So this documentation explains why we're seeing what we're seeing as we type in read CSV. Now, if I hadn't pointed this out to you, it might take you a little while of reading and scanning and navigating this to have found that explanation, but you can see this is consistent with the behavior of the function, or at least it should be. All right. If column names are passed explicitly, then the behavior is identical to header equals none. So let's maybe try and add a parameter here, and let's say pd.read CSV and flags data URL, and I'll say header equals none. All right, And we'll save this to flags again. And we'll look at the first 5 rows. So you'll see if we use header equals none, now it's not inferring the header from the first row. It's just saying, oh, there is no header, so let me just put in integer values as the headers. But you'll also notice that now Afghanistan is in its proper place as the first row of the data set. Now, if I wanted to access just the names of the countries here, if I wanted to look at just this first column, I could say flags. And let me see if this works. Flag 0, right? Now I have just the first column based on its index. This might also work if I put it as a string. No, it doesn't work as a string. All right. Now, when we have data, we want our data to be easy to understand. Now, what we prefer is that these column headers not be integer values, but that they come from the data dictionary, right? That they reflect what these columns actually represent. All right. Yeah, and Gwen makes a good point that whenever we're counting in Python and when we're working with code, we start with 0 typically. So you can get used to this being row 0, column 0. And then that, if that's not already something that you're comfortable with, it will become more comfortable over time. So that's a good point. But what I want to show you is I want to show you how we can take column headers and explicitly set the column headers on this data set. Now, what's the annoying part is that probably the easiest way to do this is to type out all of these column headers. So what I've done is I've done that for us. And now let me just give you those column headers here in Slack. All right. So if you copy and paste what I just gave you in Slack, you will have all of the column headers written out. That way we don't have to just type together for minutes and minutes and minutes, right? So here's my column headers. And I'm going to try and read this in one more time. All right. Flags equals pd.readcsv, give my flag data URL. But now, let's see, I've got this list of column headers. What parameter should I use here to assign those column headers, right? So take a look at the documentation here. Which parameter should I use to give those column headers or to assign them to the different columns? Oops. Okay, so we got a couple different ideas. Use calls list-like or callable optional. Returns a subset of the columns. If list-like, all elements must either be positional or strings that correspond to columns. So I think use calls, however you want to say it, I think is a way we can get a subset of columns. So saying, okay, read in this data set, but don't keep all the columns, just keep columns 0, 1, and 2. All right. I think what we want is names. List of column names to use. If file contains no header row, then you should explicitly pass header equals none. Duplicates in this list are not allowed. All right, so we'll say header equals none and names equals column headers. Ta-da, we have column headers. All right. So Travis, the reason why mine says DS10 is because I physically went and renamed it. So don't worry if yours looks like this, that's good. Then you're working with the right version. Mine says DS10 because I'm going to leave you this version as the lecture notes, and I want to make sure it's explicit that this is the lecture notes for the time this lecture was given to the DS10 cohort. Yeah. So you're on the right track. All right. We have a person that says, my computer gave me an error when trying to look at the raw data and said I don't have the right software. You need to have some kind of a text editor. So a text edit or Sublime Text or something like that. Remember, this is my Sublime Text, where you can look at raw text files. Otherwise, you're probably going to need to use the curl method here inside of Google Colab. to look at the raw version of the file. Does clearing the output still keep what was performed on the cell? Yes, it does. So anything in the memory of the notebook will stay the same. It's just gonna remove the output so it doesn't show it anymore. All right. Do we have to include parameters in the correct order, or can they be in any order? Typically, they can be in any order. Now, it depends. All right. So here on, we have file path or buffer. This is truly the name of the parameter. All right. So let me scroll back down to where we were loading data sets. If I include the name of the parameter, then I can move it wherever I want. Let me actually not do that here. Let me do it down below. Like this. If I say file path or buffer equals flag data URL, then I can move it. And it should work just like before. But if I don't have the name of the parameter included, then it tries to go based on the order of the parameters, and it will probably complain to me, right? Positional argument follows keyword argument, right? So typically, the non-named ones need to go at the beginning. And it's going to say, okay, well, this is the first parameter that came in. This must be the file path or buffer. And then it's going to say, oh, this one's explicitly the header parameter. This one's explicitly the name parameter, et cetera, et cetera. All right, so you can change the order if you include their names. If you don't include their names, they need to be in a specific order. Good question. All righty, so, but at this point, we're good to go. We've got the data set in, and it's looking good. We can now use this data set to do some machine learning fun stuff. All right, but remember the process when uploading something, a data set you've never seen before. First off, learn as much as you can about the data set so that you know what to expect once you've got it loaded in. Then look at the raw version of the file just to make sure if you see anything wonky going on. If we knew to look for this, we could have seen at the very beginning that, oh, there's no column headers here. We could have been prepared for that. Otherwise, if you run into issues that you don't expect, first go to the documentation and see if you can figure out what's going on. And if the documentation doesn't do it for you, Google some things, reach out to your team lead, talk to fellow classmates, right? Try and figure out why things are not happening the way you would expect. But oftentimes with these functions we're using, there's lots of different parameters we could pass to change their behavior. The question is really, how well do we understand those parameters so that we can control how these functions operate? All right. So objective 2, we want to load a data set again, but we want to load it from a local file. All right. In order to demonstrate this, I'm actually going to upload a different data set. So I'm going to go and I'm going to download that data set, and then I'll give you the link to where it's at. But here's what I want you to do. Imagine you had a local file that you wanted to upload to Google Colab. What I want you to say, what I want you to tell me in Slack while I'm going and grabbing the link to this data set is I want you to tell me, what would you type into Google in order to learn how to upload a local file to GitHub? All right. And also, I'll comment that Robert is correct. The positional arguments and keyword arguments. We'll talk about that a little bit more, a little bit later. And I'll also make a comment on what Yuhan has said. That yes, this little beaker icon, you can opt into a beta version of Google Colab that has some more features. So if you've seen the autocomplete and other things popping up on mine, if that's not happening on yours, and you're like, oh, I wish my Colab did that as well, go ahead and click on the beaker and you can opt into some of the newer features. All right, but I'm going to go to UCI while you guys are typing out your answer to my question. Actually, this should just be on the home page. All right. So similar to what you're going to do during your assignment, I'm going to start with the adult data set. Now, because I'm using this one right now, it's off limits for your assignment. You can't use the adult data set on your assignment, because if you do, you'll just be doing exactly what I'm going to show you right now. All right. But I'm going to go to the data folder, And I'm going to download it. And then I'm going to show you how to get it into Google Colab. All right. Got lots of good answers. Upload local file to Colab. How to upload local file to GitHub. How do I upload a local file to Colab? Good. How do I upload a local file to Google Colab? Good. Lots of similar answers here. My 2 cents would be, when you're Googling things to try and get some help from the interwebs, don't be afraid to be verbose or type lots of words, and don't be afraid to be specific, right? So I can say, how to upload local CSV file to Google Colab using pandas, or something like that, right? Now, this get started, 3 ways to load CSV files to Google Colab. It's kind of cool. This article was written by a Lambda School data science student, and it's become really popular. And I'm going to copy, see how everyone's highlighted this version of the code. It's the top highlight from his article. This is because this is the most important code of the whole article, right? You could read and say, oh, from local drive. Cool. That sounds like what I want to do. Come here and say, from Google Colab, import files, uploaded equals files.upload. And as I run this, it's going to give me a prompt to choose files. And then I can go to my downloads, my adult data set, go ahead and open it. And it's going to show me the percent loaded as it loads all this. All right, so this is a new data set. Now I'm kind of contradicting myself because we haven't looked at this yet. I mean, I could say curl, and then let's see, this is still flags. Here's the adult data set. Copy link address. All right, so here's the raw data again. The reason why I didn't do this immediately is because this is kind of a big file. It's got like hundreds of thousands of rows, I think. Oh, sorry for the abrupt scrolling. Get back down to where we were. All right, so here's the raw file. Do you see column headers on this file? No, at least I don't, right? So we're gonna have to deal with that again. All right, good. So one cool thing is that here in Colab, once you've uploaded a file, you can check to see that it's in your Colab memory, right? So you may or may not have noticed this little tab, open left pane. Go ahead and give that a click in your Colab, and you'll see first off the table of contents, so you can get down to some portion of the notebook that we're working on. Code snippets help you do things. I don't really ever use the code snippets thing, but you could. And then files. Files is really what you're interested in here. You can see that here's adult2.data, which is what I uploaded, right? So I can see that, yes, this file has made it into my workspace as I uploaded it. What I'll also show you is that in this tab, you could do the same thing that we just did, but using the kind of the graphical user interface here, using just these buttons. You can click the upload button, adult2 data, open, blah, blah, blah. Wait for it. It's uploading. It's thinking. There we go. Then hit refresh once it's uploaded. And, well, if I hadn't already uploaded something with the same name, I think it would show 2 versions. But I think it probably overwrote the one I uploaded the other way. All right, so those 2 ways to get a local file into Google Colab, here using the side panel and the upload button, or using the code here. Now, I typically prefer to use the code a little bit more often. Now, the reason for that is that the whole reason of using IPython notebooks, the motivation behind it is to make our code shareable and reproducible by other data scientists, right? If I leave code in here and somebody else gets my notebook later on and they're running it from top to bottom, going and seeing all the good work that I've done, when they get to this step, they'll say to themselves, they'll run this cell and they'll say, oh man, I need a file. I can't make anything else in the notebook work unless I have the right file, right? So leaving the code in here just explicitly will tell somebody else who's coming through later on that, in order to do the rest of what we're going to do, they're going to need the actual data set. So I think this is a little bit more explicit, helpful for anyone who might come along in the future. But you'll know this, I don't think this code is super intuitive. I have to Google it frequently to remember this little snippet. So again, you're not going to memorize absolutely every piece of code you ever use. You're going to Google things. You're going to look at documentation. You're going to make notes for yourself that you can refer back to. So again, don't feel like you need to memorize absolutely every little thing, but I use the code snippet more frequently than I use the side panel. But that's just me. You can use your preference. Oh, so method 2, using the graphical user interface. We did it. I'll just make this comment saying that we uploaded it. All right. So this afternoon on your assignment, you're going to choose a new data set from UCI, right? And you're going to upload it using both of these methods, both using from the URL and from the local file. All right. How do you access the file if you use the GUI method? Great question. I'm going to show you that here in a minute. We'll just use the file name. All right. So even though I've uploaded the file, we haven't actually read it in. So actually, I'll just read it in here. Right. So I'll say df, which is short for data frame, equals pd dot read CSV, and then I'll say adult 2.data. You might not need to have the 2 in there. That's just yours would probably just be adult.data. All right. And then we'll say, well, actually, let's just run it. df.head. Here's my data set. Yet we notice we have the same problem as we had before. It's reading in a row of the data as headers. So I can say header equals none if I want, and that will replace the header with just integer values. Or I can type out all of the column headers, which I believe, yet again, I've done for you. So let me share that in Slack. I've got to get down to where I did it in my notes. All right. So here come the column headers. And I'll paste those in for myself as well. And I'll say names equals column headers. And there we go. We're ready to go. One thing I'll point out is that pretend that I forgot a column header. As I was typing this out, I accidentally skipped one. What would pandas do? Well, it reads them in like normal, but it starts from the right-hand side and reads from right to left, right? So now it's thinking that this integer column is the index when it's not. That should really be the age, right? Notice that this is bold when before it wasn't. Right? Here's the age column. If I let's take 2 column headers out. Well, now it thinks that both of these are the index, right? So just know that it assigns column headers from right to left. So if you leave one out, your farthest left column might get read in as the row index. So if you see a row index that's funky, then you might know that you accidentally skipped a column header. Also, Pandas does not allow duplicate column headers. So if you accidentally put one in twice, it's going to complain. Duplicate names are not allowed. All right, and, then you know to go look through and find where you accidentally put the same one in twice. All righty. All right. Okay. How do people following our notebook know what files we've uploaded? Do we just leave a comment? Yeah, I suggest that. That's actually a great idea. You know, say, hopefully you've emailed them the file or they have it, or say, you can access this file on GitHub at http://github.com, blah, 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 right? And you link them to someplace online where they can access the file. Yeah, so that way you can kind of transfer them the file without having to provide it within the document. So that's a good question. Okay, at this point, I've showed you objectives 2 and 3. All right, so in the next 15 to 20 minutes, I'm going to show you objectives 4 and 5. All right, I'm going to show you how to use some of these basic exploratory data analysis functions and how to make a couple basic plots using our data sets. All right, so with the adult data set here, we're going to use some more pandas functions to explore this data set. Get back down to where I was. All right. And I'm not gonna show all of these. I will show up until here. All right. And then we'll leave these other 4 for another day. All right. We will get to these. We'll use them frequently throughout the course, but I'm going to just focus on these first 6. I think they're the most important ones, and due to time, probably the most valuable ones to take a look at. All right, so first off, you'll notice that DF here is a prefix. This is just whatever I have named my data set after I've read it in. Now, lucky for us today, I also called it DF. We didn't call the first data set DF, we called the first data set flags. So if I was doing this on the flags data set, I would say flags.shape, flags.head, flags.dtypes. All right, so I can say flags.shape. This tells me the number of rows and columns, right? So in the flags data set, I had 194 rows and 30 columns. Now, if I want to look at the adult data set, I'll do df.shape because that's what I called it. Remember, that's the variable name that I gave it. And it tells me I had 32,561 rows and 15 columns. All right. Now, what if I do df.head? We've already looked at this one. It'll show us the first 5 rows. But here's a question I have for you. After I did df.head, df.shape went away. Why am I only seeing the second one out of these 2 commands? Why am I only seeing the second of these 2 commands? Good, good, good. Looks like a lot of you already know this, right? Only the last thing to be returned in a collab cell gets outputted, right? So df.shape will not be outputted unless I explicitly print it out. All right. So if I explicitly print it out, now I can see both. Like if I switch the order of these, then I'll only get df.shape, right? Because now it's the last thing to be happening here. Now if I go and explicitly print out df.head, it will still print it out, but we'll lose some of the formatting. All right, so still the first 5 rows, you get some truncation and other things going on. Doesn't have the nice formatting because it's from a print statement and not from the default pandas output, but I have to print everything that I want to see except for the last line. And this is just a weird thing about notebooks that you'll have to get used to. So don't get confused if you're not seeing everything. All right, just know that everything except for the last line, you'll need to print it out in order to see it explicitly. Does this apply to any text editor using Python or exclusively Colab? This is any text editor that renders IPython notebooks.ipynb. Yep. So a raw Python file that had the suffix just .py wouldn't have this problem, but all notebooks do. Yeah. Okie dokie. All right, so those are the first 2 commands. Now we want to also show df.dtypes, which is short for data types. All right, so each column of my data set contains a specific kind of information, hopefully a uniform kind of information, right? So my age column holds integers. My work class column holds strings. So any column that has string values in it will be called object, right? Object is a more vague name than string, but that's how pandas indicates columns that have string values within them. It looks like I only have ints and objects. If I had something that had a decimal portion, was like 9.0, 7.0, 13.0, then it would get a float data type, for example. Now this is important because, and as we'll learn later on this week, as we work with specific columns, sometimes the type of data that it holds dictates how we can work with that column, right? So I could say, let's say if I did df.age times 10. You know, here's all my ages times 10. The only reason this worked is because df.age was numeric. Well, what if I tried to do that to work class? What if I tried to multiply work class by 10? Well, then it takes the string and it repeats it 10 times, right? So the way that my columns react to the same piece of code is dependent on the type of data that's held in that column, all right? But we have a really good question from Faraz. He says, if you had a column like age and there was a missing value filled with man, would it return as an object, not int64? And that is a really good question. Well, and it gets to what I wanted to show you next. Well, maybe, well, we'll check for null values here in a minute. And that's something kind of where we'll maybe end some of our exploratory data analysis. Let me show you df.describe and value counts first, and then I'll get back more to your question, Faraz. So this is just an example. I'll put a little comment here. The way that we work with columns depends on the type of data that they hold. All right. That's the lesson there. Now let's do df.describe. .describe will return to us summary statistics or descriptive statistics of the columns. But you'll notice I have 1, 2, 3, 4, 5, 6 columns here, whereas I had more than 6 columns originally. So the question is, why is df.describe only giving me 6 columns? And specifically, what is it using to determine which 6 columns is it's showing to me? What do you think is going on here with df.describe? Good. You're noticing the columns that it's pulling all have the integer data type. Age, final weight, education num, capital gain, capital loss, hours per week. That's what we're seeing here. Yeah, we can only calculate the mean of something that's numeric. And we can only calculate kind of percentiles of things that are numeric, right? So .describe by default will only perform operations on numeric columns. So columns of integers or floats. Yeah. So let me, anyway, we don't have any float columns here today, but it would also show the same information if we had floats. All right. I can say, well, don't .describe the numeric columns, only give me the non-numeric columns. We can exclude the numeric ones, and now we're seeing the string columns, only the categorical columns. You'll notice there's no mean, there's no percentiles being calculated here, there's no min and max, because they're not numeric. We can't calculate those things on something that isn't numeric, right? So now we're getting top here, which is the mode, right? So we've got mean, median, which is the same as the 50th percentile, and mode. So we got our 3 measures of center. It's giving us the frequency of the most common category, the total number of items in that category, the number of unique classes within that category, right? So there's 42 different native countries, 16 different levels of education, 7 different kinds of marital status within this data set, right? So this is .describe. You can use it to get numeric summary statistics or categorical non-numeric summary statistics. But you have to pass an extra parameter if you want the non-numeric ones. All right. Question from David, how can we enable auto-completion within Colab? Again, you need to click on this little beaker up here to opt into that feature. See how it says try new features? That's something that's new and doesn't come with the default Google Colab. So you'll have to opt in to get autocomplete. All right, so that's .describe. Let me show you one more, and then I'll get to our question about NANDs. All right, so the next one I'm going to show is value counts. All right. So first, I'm going to run value counts on the whole data frame. And data frame has no attribute value counts. So this doesn't work. Notice that the other ones we called on the whole data frame. We were describing the whole data frame. We were looking at the data types of the whole data frame, the columns on the data frame, the shape and the head of the whole data frame. This exploratory function works a little bit differently, that we have to call it on a specific column header. All right, so let's do value counts of maybe one of our categorical. Let's do it on marital status. All right, so df there we go, and we can see the different breakdowns. It's counting up all the different values within a column, right? It said, okay, most people have been married civilly, then never married. A bunch of people have been divorced or separated, widowed, married but the spouse is absent, married AF. They're really married. No, this means someone serving the armed forces. All right, and we would know that by looking maybe at the data dictionary, or this is census data, and so you could also get that domain knowledge from learning more about how the census is conducted. All right, but this is the value of the value counts function. All right, is that by column we can see the different quantities. Now this doesn't necessarily have to be a categorical column. All right, I'm going to say I could call this on age the same way. Oh, I overwrote age with oh no, it's working the way I want. Let's see. It's just truncating a lot. Why did I put that there? I'll tell you tomorrow how to deal with this truncating. It's actually not that bad. You can work with Panda's display options. Let me just put this here. So Pandas has default options. It'll say by default how many rows it'll show you. Let's see if this will fix it. There we go. Now we can see all the different ages. But they are not ordered, right? So these are kind of by quantities. So the most common age of someone responding to the census is 36, then 31, then 34, so on and so forth. I can also sort these. All right. Now it's from oldest. The oldest person responding to the census here is oh, this is sorted by number of responses. Anyway, we can sort it as well. I just reversed the orders, all I did. Instead of marital status, can we call by index number? That's a good question. I believe you can. So marital status is the third column, so its index would be 2. believe that would work the same. No, it doesn't. So we have to say so let me answer Mehdi's question maybe a little bit more fully. Is the way that we access columns or rows on a data set is based on its index. Now, once I have given column headers, I've specified this as the column index, right? So once this is specified, I need to use these. But for rows, right, my rows don't have a string version of the row index. So I could select a specific row using these numeric values. If I had not read this in, if I had not provided these names here and just said header equals none, and then it would have stayed as an integer value 0, 1, 2, 3, 4, 5, 6, then I could have still done it based on the integer value, similar to how I did it. Where was it? Here. Right, so you notice right here, I accessed it based on its index. But its index was numeric, whereas now that we've provided column headers, the index is not numeric, so I still need to grab columns according to the column header, according to its index value, whether it's numeric or non-numeric. Yeah, truncating just means like leaving things out, excluding certain rows, right? So the truncation that was happening was that this was cutting off some rows in the middle. Like if I set this to 20, this will only show me 20 rows. Oh, that's very weird. It's showing me a lot less than 20 rows, but this is truncation. These ellipses, yeah, it's cutting out some values in the middle. There we go. Now I'm seeing the whole version due to these display options, which you'll sometimes need to set if you really want to be able to see all of the data. Great question. All right, so the last one that I was going to get to is the null values here. If there's a question that if we had a column that had missing values in it, how would its data type show up? All right, and I'm going to answer that question. But first off, we need to check for null values in our data set. So if I do df.isNull, what this will do is it will look through the whole data set, and if it sees a value that is not null, it will say false. If it sees a value that is null, it will say true for the entire data set. All right, then if I count those up by column, it will tell me the number of null values per column. So a missing value is the same as a null value, right? Null values can actually be a few more things other than just like a blank cell or something that's set to have a value of none or null or something else like that. There's a few different ways there can be null values, but what you'll see is that this data set says that there are no null values, all right? But if we look on UCI, UCI says to us, are there missing values in this data set? Yes. All right. So something that's a little bit odd about the adult data set, and which is honestly the reason why I've picked it for this lecture, is we need to explore a little bit more. We need to dive in a little bit more because this is not consistent with what UCI says about the data set. So we need to figure out what's going on. Now, for time's sake, I'm just gonna show you what's going on. Let's look at the first 14 rows. And we'll scroll over here. Actually, I might need the first 15 rows. There we go. So here is a missing value. However, this missing value is not a null value. Null values fit specific data types like NaN for not a number, none. If this were a blank cell, then this would register as a null value, but it's not a blank cell. When there is missing data, they've encoded it as a question mark. And a question mark is not a null value. So this was not something that was detected by my isNull function. All right. So what happens is if we know that missing values have been encoded as some specific non-null value, we can handle that in a few different ways. The first way that I'll show you is we can just go and replace those values in our data set. See if I can get down to it. All right. But before I replace this, I need some kind of a null value. So I'm going to import numpy as np, and then numpy has a missing value indicator called np.nan. Let me just print it out to show you what it does. It's basically just a null value. All right, nan. All right, so I can use this. I can replace instances of question mark in my data set with np.nan, which is what I'm going to do. I'm going to say df.replace instances of question marks with np.nan. All right, and this should go through my whole data set, replace any places where there's question marks with nan values. All right, and it's returned back to me a new data set. And let's see, what if I look at the first 15 rows of my data set here? Still see a question mark. All right, so here's my question for you. Even though I replaced question marks with nan values, how come it has not been replaced? What do you think? What did I do wrong? Good. So I did a couple of different things. First off, what Eric said is that I've made the changes here, but I haven't overwritten the original data frame. So I can do that one of two ways. I can say df equals, and this will save it back over the original data frame. Or I can say in place equals true. All right. I'm just going to save back over the original data frame. This is more correct than what I had before, to be clear. But as I do this, oops, I need to say now df head 15. All right. The question mark is still there. Even after I saved over the original data frame, the question mark is still there. Any ideas why this syntax didn't work? And the reason why I'm showing this, good, and I'll let people keep typing for a minute, is this is something that might happen to you as you're doing things. And I love the kind of questions you guys are answering. That's exactly the way I want you to think, is as this is still failing. This is failing silently, as we say, right? Meaning that, well, there was no error that was thrown by the code that I wrote, and this actually truly is the correct syntax for df.replace. I'm doing it correctly, but it's not doing what I thought it would. Yeah, and I love the questions you're answering. Maybe there's leading or trailing spaces that are off. Maybe it's been a category. Maybe it's been encoded using a different character string. You know, both of those are great answers. Now, there's a few different ways we can look at this. What I'm going to do is I'm going to show you how to inspect a specific cell. All right. So I want this to be from the native country column. And I want it to be from row 14. Good. And you'll see that in this case, there's a leading space before the question mark. So I can't replace something. I can't replace question marks with nans if there are no question marks in the data set. If I put a space in front of here, then it gets actually replaced with nan. All right, so this is a problem you might run into that's a little bit nefarious. It might take you a while to figure that out, but what I want you to think about when you see something that's not happening the way you expect it to, first off, double check your syntax, and if you're sure that's correct, go to the source. Find one specific instance of it and see if you can maybe investigate further, see what's going on. All right. Now, there are other ways to inspect this. So if I look at it now, it's now a nan value. I could also say df.ilock, and I will need to pass this index value. So this is column 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, I think it's rows first, so 14. 13. And maybe this is, oh, I think this is square brackets. There we go. A different way of getting at it. So going along with the question of, well, can we access values by their index value, by the numeric index value? Yes, you can, just not inside of these default square brackets. So you have to use a different function like the ilog function. Anyway, there's different examples of how we could specifically investigate and look at this specific value. In our cases, I think we could also do .loc. Oh, that's not working right. Anyway, I thought that would work. But what I hope you also see as I'm doing these things is that this syntax, I did it wrong the first time, right? I don't have it exactly right, you know, out of the holster every single time. And I can't tell you how many times I've even demonstrated this exact principle in this exact lecture, right? And even then, I didn't get the syntax right the first time, right? You'll have to look things up constantly. You'll make small, silly syntax mistakes, but you'll get better and you'll persevere through them and get better and better. Why do we have to use np.nan instead of just replacing with nan? That's a slightly complicated question. The real answer is that pandas is using NumPy under the hood. These columns and rows of pandas are truly NumPy arrays. And so in order to get it to work with NumPy, we use the NumPy nan version instead of something else. One of these things where here at Lambda School we practice what we call, what's the term for it? Anyway, here's the term: progressive disclosure of complexity. All right, so progressive disclosure of complexity means today, take my word for it and just use np.nan for your nan characters, and we'll get more into it. Python's none should work as well, because none is also a null value. So none would also be detected by is null. Also an empty string would work, et cetera, et cetera. But yeah, can't teach you everything about Python in our first lecture, or about pandas either, right? So now if I do df.isNull.sum again, now that I've replaced those things with null values, I overwrote with my data frame. What did I do? It's only seeing one null value in native country, and that's not correct. Let me rerun some of these cells. I think I need to go all the way to the beginning, which is kind of awkward. Need to reread in the data set from the URL. All right, here we go. From the file. And if you hold shift as you hit enter, it'll just run all of your cells one by one time for each time you press enter. So that's the keyboard shortcut for running a cell. All right, there we go. I had accidentally at some point overwritten my data frame with, I think, just the first 14 rows of the data frame. So here's truly the number of null values. You can see that, yes, there are lots of missing values in this data set. All right. Do regular expressions work if there are different variations of spaces plus, and I want to deal with them manually? Yes, you can use regular expressions with pandas. You have to use an R string sometimes. If you don't know what I mean about when I say that, don't worry about it. But the short answer is yes, you can use regular expressions. All right. Very last thing, last objective. These are the main exploratory data analysis functions I want you to be familiar with today, right? So just be able to run them. You'll notice that running them is a one-liner, right? You can do df.head pretty easily. You can do df.isNull.sum pretty easily. You can do value counts in a one-liner, so on and so forth. Should be not too bad, but we will use them also over and over again. So the last thing I want to show you is that Pandas has some built-in functionality for making really basic plots. After we see some of the basic summary statistics, the data types, missing values of our data set, we often want to know things about the distribution of specific variables, right? So we can start to make some good decisions about how to treat our data how to use it. So the thing we want to do is we want to, first off, select a specific column, right? So for example, if I select the age column, and then I call .plot on it, this is going to look really nasty, all right? And your guys' first plots might look something like this. There's a line plot of the age, all right? So let me tell you what's actually happening here is the x-axis here represents the different row of my data set, and the y-axis represents the age of that row, right? So you're seeing that the age varies a whole lot, and so this is jumping around in such crazy ways that we can't even really make sense of what's going on. Well, what I can do is I can combine different things. So I can say value counts on the age, right? And then plot, oh, got to type value counts, right? Plot just the counts of the different ages, all right? So you'll notice that people in their 30s had around 800, and then it kind of trails off as people in their 80s and 90s had the smallest numbers. But still, this is probably not the most appropriate use of a line plot, even to this point. Now, you can see there's some funky output here. This is something that happens whenever we use matplotlib, which is actually what's working under the hood here to make these plots. I can squelch that with a semicolon at the end of the line, right? And that kind of hairy output goes away. All right, so first off, this is not a good use of a line plot, but I wanted to show you the syntax and that I can combine the .plot functionality with other exploratory data analysis tools in order to make some basic graphs. All right, you're going to get a chance to practice these more on your assignment today. So let's make a histogram. Let's make a histogram of age. All right, so, oh, and I'll squelch that output again with the semicolon. So here's a histogram of age, and by default, the histogram from Pandas has 10 bins, meaning 10 different bars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can say specifically the number of bars I want if I say, pass the bins parameter. I'll say 72 different bins. Now I've got one bin for each year. Now I see that the height of the bins is truly representing the number of people that had those ages, right? So look at the similarities between this histogram and this line plot. They're actually plotting the same data, but just represented in different ways. All right, so this is a good use of histogram. This is not a good use of a line plot, but this is the syntax, right? .plot for a line plot, .hist for a histogram. Okay. Also, a scatter plot. I could say df.plot.scatter. Now, a histogram and a line plot, they require a single variable, right? So this is just showing, connecting all the dots between age. This is just showing bin sizes. Why did I choose 72 here? That's a good question. So the reason why I chose 72 is because actually, let's just do dot describe here. Because my youngest age was 17 and my oldest age was 90. So 17 minus 90, well, let's see. It's 73. So I have 73 different ages and I can represent them by 72 different bins. Right? Maybe that would be more appropriate. Well, that's why I chose that specific number. Kind of an oddly specific number. I meant to have one bin for each year of age. Oops. Gosh darn it. All right. Me being a little bit OCD here. Sorry about that. So finally, scatterplot. Back to scatterplot. I'll give it 2 different column headers. Why does the line plot zigzag back and forth on itself? Well, because there were specific ages here where there was no one of that age or very few people of that age. So it's literally just trying to connect the dots between all these value counts. So it starts with 36 at this number, then 31 at this number, then 34 at this number. So how these numbers zigzag back and forth mirrors how the line plot zigzags back and forth, which is why I said this is not a good use of a line plot, but me just trying to show the syntax in kind of a quick and dirty way that I just call dot plot on a column of values, and it will give me a line plot. All right, value counts is just returning back to me a single column of values. All right, so scatter plot, I'm going to do the scatter plot between age and hours per week. And I get a scatter plot of age and hour per week. Now, we're doing exploratory data analysis. We come see, oh, there's a lot of ages here around 90, and there's a lot of hours per week cut off at 100, meaning that I think the surveyors, they had a maximum value. That the maximum age they could record if somebody was 90, and the maximum hours a week they could record was 99, I believe, which you might look at this and say, that's weird. That's not maybe a true reflection of how this data set should work. Maybe you would want to account for that somehow in your modeling or something like that. But this is something we can very clearly see as we explore our data through a scatter plot that would be more difficult to see if we were exploring our data in a different way. All right. And then the last thing I'll show you here, well, 2 more things I'll show you. A density plot. This is doing the same thing as our histogram, but it's smoothing it out. It's creating what's called a kernel density estimate. For now, I just want you to think about it as a smoothed out histogram. All right, smoothed out histogram. Truly, this is supposed to represent a probability distribution where the area under the curve refers to probabilities. But for now, just think about it like a smoothed out histogram. All right. And the last thing I'll show you is a crosstab. PD.crosstab between education and sex. So what is a crosstab? A crosstab will tabulate values based on categorical variables, right? So sex is categorical, both male and female, and education is categorical with the different numbers of years representing different categories. Now we can see the breakdown of education achievement by numbers of males and females in the data set. We could also use crosstabs to make cool visualizations, all right? Again, we just give it 2 different categorical columns. It will generate this table based on whatever different items there are in the column, all right? So I'm gonna save this as crosstab like this, all right? Actually, I'm gonna show you the crosstab here. I'm just gonna tack this onto the end. A crosstab, what it sends back to us, or what it returns back to us, is really just a data frame. This is just a small tabulated data frame where these are the column headers and this is the row index, right? Column index, row index. But other than that, it works just like a data frame. So I can still say plot. And here is a line plot showing the differences in achievement, schooling achievement for males versus females in the data set. And I can use different kinds of plots here. I could say, oh, we should use a bar plot here. Again, this is things we'd have to look at in the documentation. This is doing the same thing as the line plot, but instead of having those points where the line goes, kind of connect the dots between all these bars, it's just putting vertical bars. I can, right? You might not know all of these parameters off the top of your head in order to manipulate some of these plots, but that's what I want you to practice this afternoon. I want you to explore the data set that you choose. Try and learn as much about it as you can, and then after that, try and make some really awesome plots that you think capture the essence of that data set and really explain its variables as well as you can. Now, you might have to look through documentation. You might have to Google the documentation or use the help command in order to do those things. This is what I want you to focus on today. It's just, can you load a data set and learn as much about it as you can using these different tools? All right, so hopefully I've given you some syntax examples of all of the different things you'll need on your assignment, so you can refer back to this Google Colab link. I'll share the link again, but to be clear, the link I shared at the beginning of the class is exactly the same one as this one, and it should be useful to you in order for learning more about these topics, and for just referring back to syntax that you may not have really under your fingertips quite yet. All right, let me go to Slido, and I'll answer the final questions that we have. By the way, if you have any other questions before we end lecture here, this is kind of the last code I'll write. I'll answer the Slido questions, then I'll let you go for lunch. It is aggravating that df native country.value counts didn't show the leading space. That is true. Actually, all of the string values in this data set have a leading space on them. So whoever saved this data set originally and gave it to UCI, there are leading spaces on all of the strings, which is kind of annoying. But I use this data set specifically because it's got that weird thing that if you're doing it on your own, you might never figure out why it's doing that. And just to demonstrate the principle that you could be doing everything right according to what you think and still not have things work quite right, you might need to investigate sometimes. I keep on downloading the adult data set. My computer knows it's there, but when I use the code to bring it into Colab, it says it can't find it. Make sure, that's odd to me. If the code isn't working for you, try the sidebar method and see if you have any more luck. Or check your sidebar and see if it's already been uploaded or something like that. Remember, if you upload from your local notebook, you won't use the URL to read it in. You will use just the file name as a string. And if you continue to have challenges with that, reach out to your team lead and they can help you figure it out. What if my computer is giving an error and I can't download a data set to upload to Colab? If that's the case, then we'll help you do it just by the URL for both cases. There's other ways to do it as well. I'll demonstrate a method using a bash command at the beginning of class tomorrow that will show you how you can get a data set here into the memory of your notebook without uploading it from a local file. If you're interested in looking into that today, that's called the wget command. So I'll add that as a comment here. We have a question also here that says, sorry, 2 seconds. That there's lunch and learn going on. Don't worry about that for today, because we've basically gone over the normal lunch hour just due to some of the craziness of first day stuff. So don't worry about that too much. We will get to lunch and learn in future days. So don't worry about that too bad right now. I'd like to compare notes. Can you post the master version of the Colab notebook? Yes, so that Colab link that I shared should have all of the code that I've written during lecture today. If you're not seeing everything that I've written, you just need to refresh the page. But this will be the master version. This will not be put back into GitHub. So the only way that you'll have this lecture notes version is through the link that I've shared in DS10. So make sure you make a note for yourself. Maybe you want to refer back to these lecture notes on the sprint challenge. Make sure you save a copy of this notebook or something like that, a place where you can get to it. All right. When using .describe, can you get the same rows that show for non-numeric to show for numeric? Yes, I believe you can. Let me demonstrate that very quickly. So there's both include and exclude parameters here on df.describe. I believe you can say include all, and then it'll show you for everything. But it's just giving us nans for the integer values here on the non-numeric ones. But you'll see this does have all the columns of the data set. But this is not the default behavior. We have to pass this parameter. So I guess it's still not going to calculate those, which is frustrating. But yeah, so yes and no. If you have no numeric values in your data, with that df.describe exclude numbers, return a callback? No. So also, if you're coming from a JavaScript background, callbacks are not as much of a thing in Python. So if I have no numeric values, this will probably just not do anything, or it will throw an error of some kind. Yeah, so I would maybe even create a data set to test that out. Almost always you'll have data sets with both numeric and non-numeric columns, so it's pretty rare that that would happen, but could be the case. All right, and that wraps up Slido questions. So when will the recording of today's video be posted? It's going to be a fairly long video, and so it might take a little while to upload to YouTube. I would expect that by the end of lunch or close to the end of lunch, it should be available. It does take a little while for GitHub to process longer videos like this, so be a little bit patient with it, but it should be available really soon. All right. Thanks for your patience, guys. I know this is a lot of Zoom call to be on for the first day. This has been a lot of stuff, and thanks for being just awesome and for your participation, your concentration. I know this is a lot, but I hope you feel like we've made good progress here on the first day, and we didn't just do housekeeping stuff. We're actually dive in and do some real data science too. So I really appreciate everything from you guys, and I'll be available during the afternoon. You can DM me if you have questions about things. First off, please DM your TLs first. They're kind of your first line of defense, and they'll bring things to me secondhand. Also, remember the 20-minute rule. You are to spend at least 20 minutes really digging in and trying to solve your own problems, Google things, reading documentation, referring back to the lecture video, looking at the lecture notebook. And if you just totally stuck after 20 minutes, you don't know what to do next, then do reach out for help, but give yourself that 20-minute window to really build the skills of solving your own issues and Googling things, reading documentation, all those other things. All right. Awesome. Thanks, everybody. Hopefully you're excited for your first day here at Lambda School, and you'll see your skills build quickly as we get through this content. Really appreciate it. Go have a good lunch. Go take a break. Get away from your computer screens, and I'll see you back here in about an hour. Thanks, everybody.